Hello, I'm Dr. Chanak Vijayaratna, the CEO of the Sri Lanka Olympiad Mathematics Foundation. I'm going to discuss the SLMC 8 2020/21 medium questions. So if you watched the part 1 of this video series, the solutions and discussion of SLMC 8 2020/21, the first part on easy questions, right? Then you know that this competition is labeled as 2020/21 because this should have been held last year, but due to the COVID pandemic, this was held this year, right? And like in the International Mathematical Olympiad, right, questions in the Sri Lankan mathematics competitions are in three categories: easy, medium, hard, right? The first 10 are easy, the second 10 are medium, and the third 10 are hard. Now, in the International Mathematical Olympiad, which is held on 2 consecutive days, on each day, the contestants get 3 questions. The first one is easy, the second one is medium, and the third one is hard, right? So now, on medium questions, right, for each correct answer, the students get 6 points, and for no responses, students get 2 points, and for incorrect responses, students get 0 points. So you should mark a response only if you are sure of the response, right? Okay, so let's start working the medium questions. First, question 1. What is the average of these given numbers? So there are 10 numbers, right? And you can see that all these numbers are bigger than 2000. Some are actually less than 2020. Some are bigger than 2020, right? So the numbers, let's see, so 2027 and 2023 and 2029 and 2025. Yeah, this 2021, right? And 2025. So these are all bigger than 2020, and then we have 2015, 2014, and then 2018, and then 2017, and then 2016, right? So 5 are bigger than 2020, and 5 are smaller than 2020. So this, what is this 2020? So it is just an observation, right? And also the questions in the Sri Lankan mathematics competitions tend to be based on the year it is held, right? So this competition should have been held on 2020. So most of the questions have this number in the question, right? So we could actually sum all these numbers, right, and divide by 10, right? But you know that that this question is posed. So for you to solve this in a different way, in an interesting way, in a shortcut method, right? So now, how do we find the average of all these 10 numbers without adding all these numbers and dividing by 10, right? Well, so since 5 are bigger than 2020, right, and 5 are smaller than 2020, we could expect that the average to be around 2020, right? So now what if we look at the differences of these numbers from 2020, right? And at those differences, the deviations, right? So let's see, now we take 2027 minus 2020, right? Plus 2023 minus 2020, plus 2029 minus 2020, right? Plus 2021 minus 2020, plus 2025 minus 2020, right? And then the smaller numbers, right? 2015 minus 2020 plus 2014 minus 2020 plus 2018 minus 2020 plus 2017 minus 2020 plus 2016 minus 2020. Now we were supposed to find the sum of the numbers. Now what we are doing is that finding the differences of the given numbers from this number 2020, right? The deviations, right? Now for this to be equal to 2020, we need to add 2020 10 times, right? Because we subtracted 2020 10 times, so we need to add 2020 10 times. And that gives us the sum of the numbers, right? And then we divide by 10, right? So now you can see how this is going to help us to find the average without doing big calculations, right? So let me erase this part. Right. Now let's calculate these differences, right? So we have 7 plus 3 plus 9 plus 1 plus 5, right? And then we have the differences of smaller numbers with 2020. So minus 5, minus 6, minus 2, minus 3, minus 4, right? So now if I simplify this, and I get this divided by 10, right? And then this thing over 10, and that is actually 2020, right? So you can see that we have already doing the calculations, right? We simply need to find some of these numbers and divide by 10 and add it to 2020. So, so what is the answer? So here we get the positive numbers add up to 10, 10, 25, right? And the negative numbers add up to 5, 6, 11, to 13, 16, 20, right? So divided by 10 plus 2020, and this is 5 over 10 plus 2020, and this is 2020.5, right? So the answer is 2020.5, right? So see, so this is an interesting way to solve this problem, find the average without doing big calculations, right? Okay, so let's look at the next problem, number 12. So let me get rid of all this. Right. Okay. So in number 12, we are given two operations, right? One with this symbol. Okay. This strange thing happens sometimes, right? So this is now we don't have a name for this operation, right? So we can actually call it box multiplication, right? Because the multiplication sign is inside the box, right? You could also call this by any other name, right? So A box multiplication, B is you pick the maximum of A and B and add 1, right? And then we have A star B, and here we pick the minimum of the two numbers and add 1, right? So this is what we call binary operations because they are defined between two numbers, two things, right? So we simply need to find out this value, right? 6 box multiplication 5 within the parentheses. That means we need to do it first and then start with 4, right? Right. So these two operations are defined on positive integers, right? So that also you can note. And what is 6 box multiplication 5? So here we pick the maximum of 6 and 5, which is 6, and add a 1 to it, so we get 7, right? So if you start that with 4, that means 7 star 4. You pick the minimum of 7 and 4, which is 4, and add a 1 to it, then we get 5, right? So short and sweet, we get the answer 5, right? So the answer to this is 5, right? Okay, let's go to the next question, number 13. How many digits does the number 8 to the 8 times 5 to the 21 have when written in decimal representation? So 8 to the 8 times 5 to the 21, right? So when you look at this, right, now you can't do this calculation because this is going to be huge. So then how do we figure out the number of zeros, right, when this is written in decimal representation, right? Now, about huge numbers, now if you take 10 to the 100, it is a huge number. And you know how many digits, this one has. Now, this number begins with 1, and then 100 zeros follows this one, and the zeros follow this one, and that means this has 101 digits, right? So we can immediately tell the number of digits of such a number, right? So can we write this as a power of 10? Now we could, if we can get 2 as a prime factor of this, right? Now you can, bring in 2 because you can write 8 as 2 to the 3, and then this is raised to the power 8 times 5 to the 21, and then this simplifies to the exponent here is 24 times 5 to the 21, and if you combine 2 and 5 you get a 10, right? So then let's write this as 2 to the 24 as 2 to the 3 times 2 to the 21 times 5 to the 21. Again, that thing happened. So so this is 5 to the 21. Now 2 to the 3 is 8, and this is 2 times 5 to the 21, right? And 2 times 5 is 10, so you get 10 to the 21, right? Now 10 to the 21 is a number that begins with 1, and then 21 zeros follow it, and if you multiply that by 8, you get a number which begins with 8, and 21 zeros follow that 8. So this number has 21 digits, right? 21 digits, right? So the answer to this question is, right, 21. Okay. All right. So next, let's go to number 14, right? So let me get rid of this, all this work that we did for number 12 and 13. Right. Got it? Right. Now we start with the clean whiteboard. Number 14. So we have 3 prime numbers, P, Q, R, and we are told that P is less than Q, right? So if P plus Q is R, right, you can see that Q is less than R, right? So then this is the order of the 3 primes, right? And since R is the sum of 2 primes, right? And we know that except 2, all the primes are odd, right? Except 2, all the primes are odd. And 2 odd numbers add up to even, right? But plus odd is even, right? So if P is less than R, right? P is less than R, right? R actually is not 2. Anyway, you can't get R as 2 because 1 is not a prime, right? So R is not equal to 2, right? So you can see that R is bigger than 2, right? So then it's very clear that P has to be equal to 2, right? Okay, so the answer is 2. All right. Now wait a minute. Now, why should P be equal to 2 because now P and Q, right, are both not odd, right? Both can't be odd, right? So one of the P or Q has to be odd. Sorry, has to be even, right? So that means one of P or Q is 2, right? So therefore, one of P or is 2, because that's the only even prime, right? So P and Q can't be both odd, because if they're odd, it is even, and then R is bigger than 2, right? Anyway, R is, right? So that means that one of P or Q has to be even, right? And since 2 is the only even prime, so one of P or Q has to be 2, and it has to be the smaller one, right? Because Q is bigger than P, right? So Q can't be equal to 2, right? Because there has to be a prime less than Q, and 2 is the smallest prime, right? So therefore, you can say that P is equal to 2, right? So you can see that, earlier I picked the answer 2, but I didn't have the full reason, right? So now you can see that the reasoning is complete and we found the answer correctly. So we could, get the answer with partial reasoning, right? So we have to make sure that we are very sure of the answer, right? And we have reasoned it out, right? Or we have a very good guess, right? Otherwise, what happens is that if the answer happens to be incorrect, right, you get 0. And if you leave that question unanswered, you can get 2 points. All right. Okay. So let's go to the next question, right? So let me move this, scroll this down, right? Right. So number 15, right? So let's move this all the way up, right? Number 15. So we have this figure, right, made of 6 equilateral triangles of side length 1. And we know that it's actually the regular hexagon of side length 1, right? So, so let me draw the best regular hexagon I can using freehand, right? So let's pretend that, this is a very nice hexagon, right? Even though it is not that good, right? And then 2 circular arcs are inscribed in this, right? So they are actually part of a circle with radius 1, right? And we have to find the shaded region, right, as a fraction of this area of the circle of radius 1, right? Now, I think in the previous problem, we talked about regular hexagon, right? So regular polygons are they are equiangular. That means all the angles are equal. All these angles are equal, right? And they're equilateral. That means they have the same side length. So here it is 1, right? Now, what is this angle? Now, since this angle actually twice the angle of this equilateral triangle, which is 60, right? So it is actually 2 times 60. So this is 120, right? Now also we can find the angle of a regular polygon by this formula, right? What is that formula? n minus 2 times 180 over n, right? So when n is equal to 60, sorry, when n is equal to 6, what do we get here? So we get here 6 minus 2 is 4 times 180 over 6. So this is 2 and here 3. So this is 180 over 3 is 60. So this is 120. Right? So it's correct. Right? So now this circle of radius 1, right, can be divided into 3 equal sectors, right? And with this angle, subtended angle at the center, 120, right? And we have here 2 of them inscribed, right? So that means this area, right, has to be, right, 2/3 of the area of the circle, right? So area of the circle is actually, as a fraction of the area of the circle radius 1, right? So it is simply 2/3, right? 2/3. So the answer is this one, right? Okay. Okay, so let's look at number 16. In number 16, Malini has 3 different t-shirts, right? And Geeta has 4 different caps. So in how many ways can they exchange 2 t-shirts and 2 caps? So this is actually equivalent to number of ways of selecting 2 t-shirts and 2 caps, right? I just drew, rectangle with 2 boxes, right? Now, in how many ways we can select 2 t-shirts from 3 different t-shirts, right? So we can label the t-shirts as, T1, T2, and T3, right? Now, to select 2 out of 3, we just have to drop 1, and there are 3 different ways of dropping just 1 t-shirt. So we have 3 different ways of selecting 2 t-shirts. Of selecting 2 t-shirts, right? Two t-shirts. And what about selecting 2 different caps from 4 different caps, right? Now here we could actually look at this in this way. So we pick cap, right, from these 4 different caps, so that we can do in 4 different ways, right? And we pick another cap, right? And then we have only 3 choices for the second cap because 1 is gone. So 4 times 3. Now, let's again, label these caps as C1, C2, C3, and C4, right? Now, what happens is that now we could, select the C1 cap in as one of these 4 ways, right? And then C2 as one of the caps in these 3 ways, right? So C1 and C2. But we could also select C2 as the first cap, right? And C1 as the second cap, right? So these 12 ways here, right, have 2, ways are actually selecting the same pair, right? there are two actually selecting the same pair. So if we divide this 4 by 3, 4 times 3 by 2, we get, all the different pairs. And there is actually 6, right? So now here, 3 different ways of selecting 2 sheets, t-shirts, and 6 different ways of selecting 2 caps. So can we say that, we have 18 different ways of selecting 2 t-shirts and 2 caps? Well, we can look at something like this. Let's say that, we have 3 towns, A, B, C, right? And we have 2 ways of going to B, from A to B, and 3 different ways of going from B to C, right? So how many ways are there to go from A to C via B, right? You can see that, that is actually 2 times 3, right? There are 6 ways, right? And likewise, if you think that, this selecting 2 different t-shirts and 2 different caps, it's actually 3 times 6, right? So the answer is 18, right? Okay, let's move on to the next problem, number 17, right? So let me erase all this. Right. So number 17, how many 2-digit numbers are there with the property that the number equals 7 times the sum of its digits? So 2-digit numbers, right? So we should write it like this, AB with a bar with, right, to indicate that, this is not A times B. This is the 2-digit number with the first digit, the 10th digit is A and the 1st digit is B. So naturally, A has to be not equal to 0, right? Otherwise, it's not a 2-digit number, right? And with the property that the number equals 7 times its sum of its digits, so this should be equal to 7 times A plus B, right? And then we have 10A plus B is equal to 7 times A plus B. So this is a little equation that we can simplify. So 10A plus B is equal to 7A plus 7B. And then we get, if you bring 7A to the left-hand side and B to the right-hand side, you get 3A is equal to 6B. So this means that A has to be equal to 2B, right? Right, now we can give all the possible values for A. So A could not be 0, right? But A can be, so A can't be 0, so but A can be 1, right? Then B is equal to 2, right? It can be 2 and then B is equal to 4. It can be 3 and B is equal to 6. It can be 4, B is equal to 8. But it can't be equal to 5, right? Because then in that case, sorry, I got it all wrong, right? I need to, so this has to be B and this has to be A, right? So B cannot be 5 because in that case, A is equal to 10, right? So we have 4 possibilities, right? That means there are 4 2-digit numbers with the property that the number equals 7 times the sum of its digits, right? You can check, So we have 21, and this is of course 7 times 2 plus 1, right? And then we have 42, So this is 7 times 2 plus 4, and then we have 63, and this is 7 times 6 plus 3, and then we have 84, and this is 7 times 8 plus 4, right? So the answer is 4, right? Right. So let's move on to 18. So let me get rid of this. So how many two-digit numbers consisting of non-zero digits, right, are there such that the sum of the number and the number obtained by reversing its digits is 44? I see. So two-digit. So A, B with a bar weight, right? And both A and B are not equal to 0, right? And then the sum of the number and the number obtained by reversing its digits is 44. So that means AB plus BA is 44, right? So then 10A plus B plus 10B plus A is 44. And then we have, when we simplify, 11A plus 11B is equal to 44. And you can divide by 11. So A plus B is equal to 4. So now let's give values for A. So A could be 1, right? So in that case, B is equal to 3, right? And A could be 2. In that case, B is 2. And A could be 3. In that case, B is 1. And these are the only possibilities, right? So we have then 113 plus 31, of course, this is 44, and then 22 plus 22, this we get the same number when you reverse digits, 44, and then 31, right? So 31 plus 13 is 44. So there are 3 such numbers. So the answer is D, right? Okay. So let's go to number 19 and let's move this up, right? So number 19, that thing happened again. So let's erase this. Right, number 19. So let's erase all this. Right. Consider the following statements by Abdul, Meena, and Kamala about a 4-digit number. Only one of these statements is false and the others are true, right? Now, in this question, we need to look at the structure of these the statements by these 3 guys, right? Now, now we notice that the 21 is equal to 3 times 7, right? So if a number is divisible by 21, right? So then we can say that if a number is divisible by 21, then it is divisible by 3 and 7, right? Because 3 and 7 are numbers with no common factors other than 1, right? So when you divide, when two numbers divide, such numbers divide a number, then the product also divides the number, right? So then, now if Kamala's statement is true, right? So if Kamala's statement is true, right? Then I'm going to write that symbol, right? It means that then Abdul's statement, right, is false, right? Statement is false, right? Now, what happens if Abdul's statement is false? Again, you know, that thing happened. Maybe it's a bug in the Microsoft board. So if Abdul's statement is true, right, that means the number is not divisible by 3. Now, in that case, the number could be divisible by 21 if, you know, it is also divisible by 7. Now, when the Abdul statement is, false. So if this is false, right, so that means so that means, right, the number is divisible by 3, right? So this means the number is divisible by 3, right? So in that case, the number is divisible by 21. That means Kamala's statement is true if, you know, number is also divisible by 7, right? So then Kamala's statement, right, we can see that it could be true or false. We can't say, right, true or false, right? Right? So, now we have these two possibilities, right? So now other statement is, so let's make a little table. Abdul, right? Kamala. So if the Abdul statement is false, right, Kamala's statement could be true or false. So that's what, you know, we got from here, right? Now, if Abdul's statement is true, right, so that means the number is not divisible by 3, right? Then you can see that Kamala's statement is false, right? It is not divisible by 21, right? So Kamala's statement is false, all right? So that means in any case, right, in any case, we have, so the problem says that one of these statements false, the others are true, right? So we always have here one statement false, right, is false, right? So that means Meena's statement, right, has to be true always. It is true always, right? So then the number has to be divisible by 5, and from the given numbers, only this one is divisible by 5. So it can be the number, right? Okay, so hope you know that this is clear. So if not, please watch it again and make sure that you understand it, all right? Sometimes, you know, it takes a little while to understand the solution, right? So spend a little time, revisit this solution again, and I'm sure that you'll be able to understand. Okay. All right, let's move on to the next question, number 20. So let's get rid of, this work. Right. Let's move this a little bit. Right, number 20. Right. So we have these politicians in the land of liars, and they always lie on weekdays, and they don't lie on weekends. That means they tell the truth on weekends. On what days can a politician in the land of liars say, I will lie tomorrow? Now, to answer this question, we need to look at the possibilities for two consecutive days, right? So if you think a little bit, you have 4 cases here, right? So I'm going to draw this rectangle with 2 boxes, right? On the first day, the politician lies, and the second day also he lies, right? And on the first day, he could tell the truth, and on the second day also he could tell the truth. And then case 3, he could tell the truth on the first day and lie on the second day, right? And he could lie on the first day and tell the truth on the second day, right? And let's look at, in these 4 cases, right, in which cases, he can say that statement on the first day, right? Now, if, both days are days in that he lies, right? So if he says that, I will lie tomorrow on the first day, right? And that day he lies, right? So then he has to tell the truth on the following day, right? Because he told a lie, that I will lie tomorrow is a lie. So then if for it to be a lie, the following day he has to tell the truth, but he can't do that because the following day also he has to lie. So then this is not possible, right? Now, if he tells the truth both days, and if he says that I will lie tomorrow on the first day, right, then he has to lie on the second day, but he can't do that if he has to tell the truth on the second day also. So then this case is also not possible, right? All right, in case 3, if he says that I will lie tomorrow is the truth, and then he has to lie tomorrow, right? So this is possible, right? And then if he says that on the first day that in which he has to lie, I will lie tomorrow, right? Then he has to tell the truth. So this is also possible, right? So how many days we have in these 2 cases? So tell the truth on the first day. So that could be Sunday, right? Because the following day he lies. Monday he lies, fine. And then in case 4, right, it could be that Friday and the following day he tells the truth, right? So we have actually 2 days on which this politician can say, I will lie tomorrow. So only Sunday and Friday, right? Okay, so we got the answer to that. So that's the end of all medium questions, right? Hope you enjoyed this discussion, these questions, right? So I'll meet you again in the discussion on hard questions, right? Okay. Thank you. So I'll see you in the discussion on hard questions. All right.